Hello everyone, my name is Sergio, and today we'll be solving right triangles for pre-calculus. Here is the 90-degree angle, right here this square, and we are trying to find side A and the hypotenuse C. We know the value of B is equal to 4, and we are also trying to find the angle capital B, and we know the angle capital A is equal to 10 degrees by the problem statement written over here. Pause for just a while and try to see if you can find the value of A, C, and capital B. So I hope you were able to solve for the necessary sides and angles. I will go ahead and now show you how I solved this problem. So in order to solve this problem, it is important for me to recall the following formulas. Starting with number 1, and that is the Pythagorean theorem, which says that c squared, or the hypotenuse squared, is equal to a squared plus b squared. And that's so, ka, to, So stands for the sine of any angle, theta, is equal to the opposite side of that relative to that angle divided by the hypotenuse of that particular right triangle. The cosine of the angle is very similar, except that instead of opposite, we use the adjacent, or the side next to the angle, theta, divided by the hypotenuse. And then the tangent, or the TOA part, is the tangent of the angle is the opposite side over the adjacent side. So these are the formulas that I use in order to solve for the missing sides and angle. I notice that I have the adjacent side relative to this angle 10 degrees. So I know I can most probably use the cosine identity. So the cosine of 10 degrees is equal to B, which is 4, that's the adjacent side because it's next to the angle 10 degrees, divided by the hypotenuse C. So if I multiply both sides by C, I end up with C times the cosine of 10 degrees is equal to 4, because the C is reduced to 1. And then in order to solve for the hypotenuse C, I divide on both sides of this equation by the cosine of 10 degrees. And now I am left with C is approximately equal to the value of 4 divided by cosine of theta, which is about 4.06. And I will box this in because that's my part of my answer. Knowing the value of C, I can now find the value of A by using the Pythagorean theorem. So I know that c squared is equal to a squared plus b squared. So then solving for the value of A, I could subtract both sides by b squared, because I know the value of B is 4. So this gives me a squared is equal to the hypotenuse squared minus b squared. And now I can take the square root on both sides of this equation. So I can solve for the value of A, since these a squared over the square root of a squared is a equal to a, because they are inverse operations. So then I am left with this equation. And now I will plug in for the values of C and B. So C was 4.06 squared minus B, which is 4, and then I take the square of that, and then all of that square root. When we do this, we end up with a value of 0.705. So then A is equal to 0.705. Now remember, this is a decimal answer, so it's an approximation. So we put the approximately equal to sign. And lastly, to find the missing side, or the missing angle B, this value, we know that the sum of the three angles have to be equal to 180 degrees. So then I can establish the following equation, and that's 180 degrees is equal to the angle A plus the angle B plus 90 degrees. So I could subtract on both sides by 90, and this on the right hand side, 90 minus 90 reduces to 0. So then 180 minus 90, when you substitute that into your calculator, you end up with a value of 90 degrees. And that's equal to A, which is the angle that we have. So I will replace that with the value of 10. So let me just erase this portion and substitute in the value of 10 degrees plus B, which is the angle we are trying to find. So now I'll subtract both sides by 10 degrees. Here this cancels, and now I'm left with B is equal to 90 degrees minus 10 degrees, which is equal to 80 degrees. So therefore, capital B is equal to 10 degrees. So by using trigonometric identities here, by the help of the SOHCAHTOA, we were able to solve for the value of C, and using the Pythagorean theorem, we were able to solve for one of the other missing sides, A. And using the fact that all interior angles for a right triangle must sum up to 180 degrees, we ended up with the value for capital B. If you have any comments, questions, or concerns, please feel free to leave those in the comments section below. Don't forget to subscribe to our YouTube channel, as more uploads will be in the near future. And also visit us at the Q Lab, located in the second floor of the JPL at UTSA. And you have yourself a wonderful day. Go Runners!